Imagine an AI that can make world-class discoveries all on its own. And not only that, but it keeps evolving. It's constantly improving, constantly thinking up new ideas, and dropping breakthrough after breakthrough. Google DeepMind just announced AlphaEvolve. And this has got to be the wildest announcement in AI we've seen so far this year. This is essentially an agentic system based on evolution, which can autonomously make scientific discoveries. And this isn't just a concept. It has already achieved a ton of real and proven breakthroughs. For example, it has discovered an algorithm for something that hasn't been solved in over 50 years. It has discovered solutions for many problems in math, geometry, number theory, and more, which no human was able to figure out. It has made Google's data centers a lot more efficient, saving them millions of dollars. It has helped Google train their Gemini models, plus it has even helped Google redesign their tensor processing units, which are used to power their AI models. This is a legit agent with real applications, and this is just the start. In this video, we're going to do a deep dive on Google's AlphaEvolve. And don't worry if you're not a technical person, I'm going to make this easy to understand for everyone. First, let's go over what the hell this is and how it was even designed. So AlphaEvolve is basically a system that can automatically come up with new solutions and scientific breakthroughs. It's a never-ending loop, so it keeps evolving and getting better and better. At the start, the human has to tell the system what problem or task to solve. For example, they can prompt it to create an algorithm that is more efficient for a GPU. Or they can prompt it to come up with a better solution to solve this really complex math problem. They also need to provide a way for the AI to automatically assess the solution it comes up with. This is known as the evaluation criteria. The criteria must be clear, objective, and measurable. So for instance, a suitable task would be getting it to create a faster algorithm for something. And the evaluation criteria would be the speed of the algorithm. We can objectively measure this. Now, it can get way more complex than this, but as long as the system can automatically and immediately evaluate its solution objectively, then it'll work. Alright, so we've given the system a task, we've given it the goalpost or the evaluation criteria. Next, we also need to give it something to start with, like a jumping off point. The user will provide an initial piece of code to kickstart its idea generation process. And within that code, there are sections marked by these evolve blocks. So here is the start of the evolve block, and then here is the end of an evolve block. And these are basically sections that AlphaEvolve can tinker with. Now you might be wondering, if the human has to provide this huge piece of initial code, how good does that code have to be? Or how close does this code have to be to the final answer? Well, it turns out you don't really need to give it much. Even a very rudimentary initial code can work. The system can still autonomously iterate from a super basic code and come up with something really advanced. But note that the human does have to provide some sort of initial solution at the start. The human can also decide to feed it some additional background knowledge, such as references or documentation, but this step is optional. Finally, all of this information is fed into the AI system where it does its magic. Now, this framework is actually based on some principles of evolution. So let's take a quick tangent and talk about how exactly evolution and natural selection works. Let's say you start off with this initial population of zebras over here. Well, these zebras are going to go through life. Some of them are going to suck at finding food and they're going to starve to death. Some of them can't really run fast, or they're not camouflaged enough, and then they get killed by predators like lions. Some of them get struck by lightning or fall off a cliff. In any case, they go through life, and due to many different reasons, some of these zebras do not survive. This process is also called natural selection. And in the end, we are only left with a subset of the population. By the way, you might have heard of the term survival of the fittest, which is like the main driver of evolution. This basically means that those that have the best traits, or those that are the most fit, would most likely survive and have their genes passed on to the next generation. So similarly over here, those that are the best at finding food, or those that run the fastest and can escape from predators, those would be the most fit, and they would be the ones that survive. They then proceed to reproduce and make babies, which will become the next generation of zebras. And this cycle basically repeats again for the next generation and the next generation and so on. Note that as you proceed from generation to generation, overall the population of zebras should get fitter and fitter. That's because the weaker genes get eliminated by natural selection, and at the end of each generation, you're only left with the most fit zebras, the zebras with the best genes. So when they mingle and reproduce, this new generation should be, in theory, fitter than the last generation. Now, I'm really simplifying this, but in a nutshell, that is natural selection or survival of the fittest or evolution, whatever you want to call it. Now, going back to AlphaEvolve, we kind of see the same feedback loop. The system has a pool of ideas where it keeps track of all its ideas and how well they performed. Next, it takes in a task from the human, and based on the task, it picks the best ideas from the pool that could potentially solve this task. It then uses AI models to come up with new variations or improvements to these ideas. Specifically, it uses Gemini 2.5, Flash, and Pro, which are Google's flagship models. Now, they use both these models to have a good balance between speed and quality. So, Gemini 2.5 Flash is a lot faster and can be used to generate new ideas quickly, whereas Gemini 2.5 Pro thinks for longer and can be used to think deeper of a solution for more challenging tasks. Anyways, you can think of this step as like showing the AI models examples of some ideas or solutions that work, and based on these ideas, the Gemini models will proceed to improve these solutions or come up with even better ideas. All these new solutions are then sent to this evaluator pool to be automatically evaluated. And this is based on the evaluation criteria that the human has set over here. In other words, the system immediately and autonomously checks if each new idea actually works and how good it is. Notice that this is like the natural selection part of the evolution cycle. And then finally, only the best solutions that have scored the highest based on the evaluation criteria are then added to the pool of solutions. And these will be the inspiration for the next iteration. So this process also repeats over and over again. The AI takes the best ideas from this idea pool, and then it keeps generating new or improved solutions using Gemini 2.5, and then it automatically tests these new variations and selects the best ones to add back to its pool of ideas. Notice that this is pretty much analogous to our zebra evolution example, where only the best or the fittest zebras are selected from a generation using the process of natural selection, and then they proceed to reproduce and then create the next generation of zebras, and so on and so forth. Notice that this is an endless feedback loop. And because it can immediately evaluate the performance of its ideas and select only the best ones to continue, in theory, the idea pool would only get better and better over time. Hence why it's called AlphaEvolve. It's like evolving to become better and generate better solutions as the system keeps iterating. And that's indeed what we see. AlphaEvolve has come up with breakthrough after breakthrough. These are cutting-edge discoveries that are superior than what even humans were able to come up with all this time. So here are some impressive achievements so far. First of all, it's really good at finding the optimal or quickest solution to solve complex math problems. And one really important math operation that's used a lot in AI and scientific computing and graphics is matrix multiplication. In fact, when you use any AI model or when you play video games with a GPU, you're basically doing a ton of matrix multiplications like this. Now, what if there was a way to do these calculations more efficiently? Surely we've already figured out how to do this by now, right? Just as an example, if you multiply two of these 4x4 matrices with complex values like this, we always thought that the fewest steps it would take is 49. In other words, we need to do 49 multiplication steps to calculate this resulting matrix. And this technique was called Strassen's algorithm, which was developed 56 years ago. Throughout this time, humans were not able to think of a better solution to do this in fewer steps. But after plugging it through this AI, it magically figured out how to calculate this in just 48 steps instead of 49. Now, doing this in one step less might not seem like much to you, but even just saving one step per operation can lead to huge resource savings when you scale this to billions or trillions of matrix multiplications that are done every day in like data centers or when you're running AI models. So this is actually a huge breakthrough in terms of more efficient computing. And get this, it found this solution that no human could figure out in 56 years. This system is like god tier in terms of math. And that's just one example. AlphaEvolve also came up with 14 other matrix multiplication algorithms that are the best in the world. Much better than what humans were ever able to come up with. Here's another example. So Google has a scheduling algorithm called Borg, which helps manage and allocate resources across its global data centers. Note that this is Google's entire data center and server system around the world, so you can imagine how big this is. Well, they've gotten AlphaEvolve to autonomously create a new rule that helps Borg allocate resources more efficiently. And not only is the solution effective, but it's also pretty simple to understand and deploy at scale. So here it says the solution is interpretable, it's easy to debug, predict, and it's easy to deploy. In fact, this new solution was able to save Google on average 0.7% of their worldwide compute resources. Now again, this value might not seem like much, it's not even 1%, but if you consider the scale of all of Google's servers around the world, this 0.7% in savings translates to millions of dollars of energy and operational cost. And this new solution has rolled out successfully already. It's in use right now, so AlphaEvolve isn't just some concept. Its ideas are already being applied in real life. Let me tell you about these awesome AI tools called ChatLLM and DeepAgent by Abacus AI, the sponsor of this video. ChatLLM is an all-in-one platform for you to use the best AI models out there. You can seamlessly switch between different models, plus you can use the best image generators out there and the best video generators out there all in one integrated platform. Plus, if you're coding something, they have a really useful artifacts feature so that you can preview your generation side by side. And then for DeepAgent, this is a god tier AI agent that can do really complex tasks all autonomously. For example, you can get it to create a PowerPoint filled with content, images, and charts. Or here's another example of getting DeepAgent to browse the web and find cheap flights. Or you can even get it to make a dinner reservation. Or you can connect it to Google Workspace and automate your workflows, or connect it to Jira to create an interactive dashboard. There are so many things you can do with DeepAgent, and you can connect it to so many other different platforms. It's gonna supercharge your productivity. Definitely check out ChatLLM that comes with DeepAgent in the description below. Here's yet another breakthrough from AlphaEvolve. As you may know, Google has their own processing units to run and train their AI models, and these are called Tensor Processing Units, or TPUs for short. They're kind of similar to NVIDIA's GPUs, but these are specialized for AI and machine learning. Now, the team basically fed the design of this TPU to AlphaEvolve to see if it can come up with a more efficient design. And after a few iterations, AlphaEvolve proposed a solution that removed some unnecessary parts for a circuit. And this optimization actually helped reduce the power consumption of the TPU while maintaining the same performance. In fact, this has already been validated by the engineers at Google and is being integrated into their upcoming TPU designs. Again, just this one solution can save Google millions of dollars in compute costs every year. So not only is AlphaEvolve good at solving math problems or even coding problems, but it can also be applied to complex hardware design. Can you imagine if this was applied to robotics or aerospace design, what kind of insane inventions it could come up with? And we're not even close to being done. Here's another insane breakthrough. If you've been following my channel, especially if you've been watching my installation videos on some open source image and video generators, you might have heard of this tool called FlashAttention, which is basically used for running AI models faster without much sacrifice in quality. Well, Google basically plugged FlashAttention through AlphaEvolve to see if it can improve the architecture and efficiency even more. And guess what? Yes, it did. It freaking crushed the task. So AlphaEvolve proposed a solution that led to a 32.5% increase in the speed of FlashAttention. That's an insane amount. And with this new FlashAttention version, that means you can run these AI models and image and video generators even faster than before. Now, since AlphaEvolve is so good, you might be wondering, why not use it to improve Google's Gemini models? Well, that's exactly what they did. Now, previously I showed you how AlphaEvolve is really good at finding new ways to do matrix multiplications. Well, it also found a smarter way to break down these large matrix multiplications, which are important for running a part of Gemini. And that solution from AlphaEvolve made that particular part run 23% faster and sped up the whole training process for Gemini by around 1%. Now, again, 1% might not seem like much, but if you look at how much time and energy is spent on actually training these large language models, 1% is actually a huge amount of computing power and energy saved. Here's yet another example of AlphaEvolve thinking of a solution to an extremely hard math problem. This problem is known as the 11-dimensional kissing numbers problem. Now, a kissing numbers problem is a classic challenge in geometry. It basically asks what's the maximum number of non-overlapping spheres that are touching a central sphere. So notice that all of these purple spheres, which are not overlapping, they are all touching a central red sphere over here. Now, the spheres in this photo are three-dimensional, right? It has a width, a height, and a length. That's like the basic 3D sphere shape that you and I are familiar with. But in math, you can actually get more abstract than this. You can have a sphere that has 11 dimensions, which is so abstract that you can't really visualize it here. So just pretend that instead of 3 dimensions, you can scale this up to 11 dimensions. Now, the previous best known answer for this kissing numbers problem for a sphere with 11 dimensions is 592. In other words, you can have a max of 592 non-overlapping spheres touching a central sphere that has 11 dimensions. And that was just how it was for decades. No one could prove a higher number. We just accepted this as the best answer. Well, scratch that, because AlphaEvolve just discovered a new configuration where you can fit 593 non-overlapping spheres to this problem. Now, if this is way too complex for you to understand, don't worry about it. I mean, what freak out there thinks about things in 11 dimensions anyways? All you need to know is that AlphaEvolve found a new and better solution to this problem, which hasn't improved for decades. No human ever was able to figure out a better solution, but AlphaEvolve could. Not only that, but it was given over 50 extremely challenging mathematical puzzles in a ton of areas like mathematical analysis, geometry, combinatorics, and number theory. And for roughly 75% of cases, AlphaEvolve came up with a solution that was as good as the best existing solution. And get this, for 20% of the cases, the answer was even better than the best solution out there. Again, it's coming up with breakthrough after breakthrough after breakthrough that's even better than what humans were able to figure out. Alright, so that was a long list of examples, but hopefully you can see how crazy this AlphaEvolve is. This is like a god-tier AI that can come up with breakthroughs in a diversity of subjects, from quantum mechanics to hardware design to number theory, geometry, and more. As long as the solution can be autonomously and objectively evaluated, then this AI is basically able to think of better and better solutions and eventually think of a breakthrough that even the best humans out there could not solve. I mean, this is it, guys. This is an AI that can autonomously do research and come up with amazing new discoveries and breakthroughs again and again. And it keeps evolving and getting better. I don't know about you, but I'm super excited about the future and all the crazy innovations we can start to see in the coming years. By the way, here are some other insights that are kind of overlooked. First of all, note that Google had this technology for at least a year. They've been secretly running AlphaEvolve all this time to make all these upgrades to their company operations, like improving the efficiency of their data centers as well as improving the design of their TPUs. Can you imagine what cutting-edge technology they have right now that they haven't told us about? It might be significantly crazier than AlphaEvolve. The second thing to note is that this isn't some new super intelligent AI model. They're using models that you and I both have access to, Gemini 2.5 Flash and Pro. It's just that they've built an additional framework around these AI models where they can iterate in an endless feedback loop. And because of this framework, you can potentially plug any model into here. once Google has Gemini 3, they can plug that into this framework and have it generate even more mind-blowing breakthroughs. Now, while this is pretty amazing, there is one huge limitation to this, which is that the ideas the system comes up with has to be immediately and autonomously evaluated given some criteria. So this only works for certain verifiable subjects like math or physics or coding, where you can kind of instantly verify if the answer is correct or not. It would be much harder to apply this to other scientific domains like biology or chemistry, where, for example, you don't really know how a cell would react to a certain type of drug unless you test it out in real life. So at least for now, with this framework, you can't really get it to create cancer-curing drugs or anything like that. Anyways, that sums up my deep dive on Google's AlphaEvolve. I'll link to this main release page, as well as their technical paper in the description below. Now, this was quite a technical and complex article, but hopefully I made it easy to understand for you. Let me know in the comments what you think of this. As always, I will be on the lookout for the top AI news and tools to share with you. So if you enjoyed this video, remember to like, share, subscribe, and stay tuned for more content. Also, there's just so much happening in the world of AI every week. I can't possibly cover everything on my YouTube channel. So to really stay up to date with all that's going on in AI, be sure to subscribe to my free weekly newsletter. The link to that will be in the description below. Thanks for watching, and I'll see you in the next one.